Okay, so looking at problem 2. So it's based on a population from the 1980 census of Naalehu County. Hawaii resident is 39 years with a standard deviation of 22.6, and the data is normally distributed. So we're looking at a sample population, so a sample size of 100 residents are surveyed, and we want to find the interquartile range for the average age. Okay, so let's just write out some information. So we know that our average here is 39 years of age. Our standard deviation or sigma is 22.6, and then we know that that's population is normally distributed. So we take a sample of 100 in there, and what we're looking to find is the interquartile range. So, and if we look at a normal distribution, okay, and we know that this is the mean here, right? And what it says is that the interquartile range is basically the middle 50%. So if I look and I split this here, and this is 25%, this is 25% of the data falls in here, 25% of the data falls in here, 25% of the data falls in here. Okay, so our interquartile range is just simply the range between this value and this value. I'm going to call this value x1, and I'm going to call this value x2. Okay, and this is my mean, or we call that my x bar. All right. And so I just want to know the difference between those values. So the first thing I need to do is figure out for a normal distribution where this is 0 to, where this is 100%. So I would need to know what are the z values that go here and here. And so there's a couple ways you can do that. You can look up the z values just in a table, or you can use the inverse normal on there. But for this, so for the IQR, to find that 60%, so we actually know that our first z value, or our left z value, is negative 0.674. Okay, and because it's symmetrical, I know that my second z value is just the opposite of that. So it's positive 0.674. Or we could say that our z values are plus or minus 0.674. Oops, 4. Okay, so now we need to find the values that correspond to this, that correspond to our data. We know that our average value here is 39, and so what we need to do is we need to find the ages that correspond to these two values here. So we need to find this x1 and x2, and so in order to find those, I can use the formula here that says that to find my x value, my x is equal to my z value times the standard deviation plus my average. Okay, and so I'll have two of these, so I can calculate x2 is going to be 0.674 times my average, which is 39, and then times my standard deviation, which is 22.6, and then plus my average, which is 39. And my x1 value is going to be the same thing, just with a negative 0.674. And so if I plug those into a calculator and go ahead and calculate those values out, I get that x2 is 54.23. It's 2324. And then x1 is 23.7676. So that means my first value there is 23.76, and my second value there is 54.23. So that means that half of the people in this county are between the ages of 23.76 and 54.23. So that would be half of those. So our interquartile range, our IQR, is just simply the difference of those. So 54.2324 minus 23.7676. And so we end up with an IQR of approximately 30.47. That's what that works out to be. Okay, so there's a range of just about 30.5 years of age. So half of the population is 30.5 years above that, and half of the population is 35 or 30.47 years below that. So there's our range of values there. So the from here to here, 30.47. All right.